All right, thank you for all of your attention and time. The thing I love about sort of the morning session is apparently without any coordination, we kind of landed at very similar kind of topics. We're really in sync about what we think is apparently important about this area, which is benchmarking and reflection. So I want to talk a little bit, since Sasha said I can give a non-academic talk, about sort of lessons from the Alpaca project and just sort of the relationship of academia and open source and what we can learn from the open source community as academics, and maybe some of the other way around. So I won't do too much of a setup, but just to set the stage, many of my students and myself, we were incredibly interested in this question of instruction tuning. We were really quite late to the game. Hannah in the back and others have been studying this for much longer than we had. But we had sort of seen with ChatGPT and others just how sort of amazingly good it was following instructions. And Daphne had said yesterday, like, why don't people work on controllable generation? And I think many of us in the room had also, worked on controllable generation. And if you had dumped something like the left-hand side text, this is from Sparks, which some of you I'm sure hate. But if you dump something like this on the left, into a controllable generation system, there's no way it's going to nail all of sort of the conditions that you throw into this, right? So in many ways, there was a kind of amazing artifact that we really wanted to understand. And sort of closer to my heart, I'd been studying sort of summarization systems for a bit, and the instruction-tuned models were really, really quite good when you started to evaluate them on humans. They were sort of on par with human freelance writers. And we hadn't really understood what exactly was going on in that. And I think, I guess more than a year ago now, there was kind of active debate about what really mattered in things like Text Da Vinci 3, or at least in my mind, there was a lot of uncertainty. There was supervised fine-tuning happening. Obviously, we didn't know what data they were using to do that, so maybe the data quality was really good. Maybe the RLHF was somehow magic sauce. Because of kind of the opacity of the whole process, we didn't really understand what was going on. And this really was the original motivation for a lot of us, that instead of trying to innovate and do something new, maybe we could just start by replicating or some attempt at replicating this instruction tuning process. And if we could do that, then maybe we can learn some things that we could use. And I won't talk a ton about the academic work, just a couple slides on Alpaca Farm and some of the academic side of what we did. And at least at a high level, why I thought this was kind of an interesting set of things to do. One of the things that we've been concerned about for a while is the high cost of running experiments, the increasing cost of running experiments, the complexity of doing so, and the irreproducibility when we rely on crowd workers. I'm sure all of you have experiences of reading a paper with crowd workers, trying to reproduce the process and being like, actually, none of that really reproduces for us. And so one of the things that we thought was, if language models could act as maybe noisy but reasonable, proxies for human annotators, then we could have some sort of a simulator, like a low fidelity, low cost simulator that could tell us a little bit about, what kinds of algorithmic interventions or data-centric interventions might be helpful in improving these models. And so we were kind of thinking about this as a kind of simulator. And I'll just flash up two sort of main findings. This is not at all surprising now, but one thing that was surprising is you can get a lot of this sort of synthetic or API-based feedback from GPT-4 or Text Da Vinci 3 or what have you, and that's actually correlates pretty well to what we can get out of a carefully filtered set of Amazon Mechanical Turkers. On the left, we're training and evaluating models using this kind of feedback on the x-axis. And training and evaluating models with human feedback on the y-axis, and we end up with sort of pretty tight correlations in terms of what we see in the ranking of systems. We also see at an individual example level pretty high correlations between humans and API-based models. And sort of the original thing that we set out to do, which was, I guess, a pair of things. One of them was to try to replicate what was in the Instruct GPT paper, but in a way that we could understand and completely control and replicate. We see that sort of, as the punchline of this Alpaca Farm series of projects, where we take a Llama 7B, we supervise, fine tune it, and that's much better. And then we do PPO, and that gets even better, at least in terms of this sort of pairwise comparison win rate. And then the other finding, of course, is that using sort of what we're calling simulation, you can call it API-based distillation or data generation, basically gives us the same kinds of results as humans. So that's all well and good, and this is sort of the part of the academic stuff that I'm excited about. But at a high level, I think the thing that's interesting to me and the thing that I've been thinking about a lot is, this question of, can we build low-cost surrogates to the objects of interest so that we can do research much more quickly, we can do it in a more distributed way, we can educate students. That all seems like really important stuff, right? And so both the data and the compute necessary to replicate, frontier models like increases every year, right? Probably, not quite exponentially, but, super linearly. But actually, like one fun fact is, I come from a computational biology background. This is actually far from a unique challenge, right? You talk to anyone that does drug development, and you see these really grim charts where you have to take hundreds of basic science findings, and one of them turns into a drug. I think my hot take here on this talk is really we should acknowledge the fact that our field is becoming very quickly like this, that we need to start thinking about pipelining strategies of how to take hypotheses to real systems, and to think about low-cost proxies, like essentially the mouse model of a language model that we can experiment on very quickly, that we somehow trust the conclusions to. So in that way, Eugene's talk yesterday about RWKB was really interesting because it was starting to talk about some of this. How can we test ideas really cheaply so we can have a distributed collective of people contributing to LM development? So, okay, so that was, all the academic side. And now I want to talk about kind of the open source non-academic side. And part of the thing that was, at least to me, also interesting about the Alpaca series of projects was that we were experimenting with things that I think were decidedly a little bit less standard in academia. We were focusing on just artifact releases and tooling, usable things for other people. We were trying things where we had multi-person teams with complete credit sharing. I had 5 of my 6 graduate students at the time just only working on this with no other things, and they were completely sort of a flat sort of credit sharing process. And then finally, trying to learn from what a lot of the sort of hacker community is doing out there. There's a lot of interesting, exciting ideas. So I'll talk about some of this below. Okay. So one of the things that I think is has become increasingly apparent to me after releasing Alpaca the model is that there's a really thin line between products that you ship to people and chatbot research, right? And it's reflected in sort of the evaluations. Chatbot Arena is an incredibly good example of this, because in some sense, the gold standard way that we have to evaluate chatbots in the field right now is to have people interact with them and kind of give thumbs up, thumbs down. And at the end of House talk, right before, right, there was this debate of should we change the people? Should we ask them to do more intelligent, deep stuff? But in a way, I think this really captures the essence of this chatbot stuff, which is it's deeply about engagement and having people interact with these systems and have them have interest or have them feel good about the interactions they're having. And in a way, I didn't realize that at the time when we originally released it, but the Alpaca model also had a similar thing. I think it took off not because somehow it was an amazing multitask model, the benchmark numbers weren't that different, but in some sense it took off because it was a really compelling experience for random internet users that were interacting with it. And I kind of think that changes, at least in my mind mentally, how I need to think about the research and the artifacts. I think my mind was still very much stuck in BERT and T5 when I was originally doing a lot of the Alpaca work. And I was thinking, oh yeah, these are research artifacts. Someone will build on these and do interesting things. But really, actually, what I was doing was releasing user-facing systems. And that really requires a different mindset in the sense that really you need to think really deeply about safety, because these are systems that people will actually be using a bunch. You need to think about actually in some sense, user engagement optimization. The whole RLHF process is basically that. And you need the system to overall be kind of polished because it's evaluated on actual user interactions. And I think the broader course of the field kind of reflects this too. If you look at Llama, 1, it was shipped with just the base model. It was a translation needed research artifact. And then you get to Llama 2 and they're yeah, this is clearly a user-facing system. We're gonna aggressively optimize all the aspects of it, right? And I think this is a sort of mindset shift that a lot of us need to maybe get into when thinking about chatbot-like language model systems. And I think there's real benefits and also like somewhat drawbacks to the fact that this is happening, right? The benefits I actually think is that it's like a really much needed shock to the system for NLP researchers. I think there was a tendency before, these like direct user interaction evaluations to just like pick benchmarks and to treat them as gold standard. But a lot of benchmarks were deeply flawed and people kept evaluating on them. I'm picking on this not because I think it's a particularly bad data set, but because I just know about them. But in summarization, people have long worked on CNN Daily Mail and Exum and so on. And those are very useful data sets at the time, but they're basically taking like bullet points from websites and like smashing them together into a summary, right? They were useful when these systems just like couldn't generate English text. But here and now, when like these systems are really good, these are actually like not good benchmarks at all. And I think the fact that real users are evaluating qualities of summaries, as flawed as it is, kind of jolts us out of this kind of mode of just being like, oh, we got benchmarks, everything's fine, right? But there's also, I think, very real drawbacks. Like kind of engagement style evaluations like really focus a lot on surface level features. And I think we as a community, both researchers and developers of models, kind of need to decide what we want, because there are kind of trade-offs between thinking about like users just playing with chatbots versus like hard capabilities of these models, right? Do they really understand language and so on? And this is a paper that's really quite lovely about humans not being gold standard and like how workers looking at like formatting and the like factuality of the actual responses and so on. So that's, I think, a really big open problem. Okay, so another thing that I learned in addition to this product versus research artifact thing is like just generally think academia is not very well designed to incentive align, particularly students, to work on large-scale collaborative open source projects. And I don't even know what the solution is, to be honest, because it's not as if academia should totally change itself and hire like great software builders that work with other people. Like in some sense, the whole point of a university is to like have places where people can like think about ideas and so on. But I think it's important to acknowledge like just how incentive misaligned things are. Like actually, one of the things I was surprised by was after I did the Alpaca thing, when I talked to people, like one of the first things they would ask me is like, how did you get like 5 out of your 6 students to just like focus on one thing in a totally collaborative way for a period of a year? And I guess my answer is actually, it was just bottom up, right? Like I just like built a community and they like self-organized into a thing. And I think a big part of it is basically a lot of them weren't interested in the traditional academic track of being like a solo investigator. And I think that's kind of a sad indictment of the system in a way. And I think the systems people have done much better in terms of encouraging open source contributions as like a core part of like an academic environment versus sort of AI, where that's, I think, lagged behind a little bit. Okay, and then the third thing, this was really a miscalibration of what I thought was like important things versus what turned out to be important in terms of like adoption of my ideas, adoption of my artifacts and so on. And so originally when I was like working through a lot of this Alpaca stuff, what did I think was very useful and what did I think would, be important? So the first thing, if you remember, I was talking about like the mouse model of, language models. And so I was like, oh, this is really cool. This Alpaca thing works pretty well. Maybe it can be like a standardized baseline that people build off of and we can like study and understand it. Well, Vicuña came and like killed that very quickly, right? None of the artifacts themselves turned out to be like relevant or stable baselines. Even now, models are constantly getting better. The other thing that I thought maybe would be, relevant and useful for other people was we collected a lot of sort of human evaluation data on how good sort of like language model based like pairwise judgments and so on were. And we thought that would be like a good sort of way for people to like trust LLM based evaluations and so on and so forth. So this is like a very like traditional, I feel like, academic point of view to things. And so now looking back at it, we can actually now like figure out what things like actually mattered about Alpaca. And I feel like it's just like totally different things. Like one of it is like, the data synthesis aspect really took off, right? Like, people are generating tons of, I wouldn't say weird, but like exotic, I would say, instruction tuning data sets using API LLMs. And that aspect has really just been like extensibility, right? Like a lot of the core ideas of Alpaca were very simple. Like anyone can just like query an API LLM and tweak some stuff and generate instruction tuning data. And that's generated like a whole ecosystem of instruction tuning data. And I think if you put on like a really grumpy academic hat, you're like, what is the value of all this like weird data that's being generated? But at least to me, it's actually been really fascinating to see like what kinds of data work and what kinds of data don't. Like the kind of, to put on like a Ludwig perspective here, right? We're seeing a lot of different instruction tuning data sets. We see some of them work and some of them don't. And that gives us some signal about what kinds of data sets might be helpful in instruction tuning. And then in terms of the evaluation, I think the thing that somehow really mattered was like the ease of integration. It was like, you know, Jan, who really led a lot of this effort, like wrote some like really easy to use APIs, and people are like, oh, automatic evaluators, really easy to use. And then so tons of people have ended up using it. And I think if you're in the open source community, these are like obvious things, right? Like PyTorch partially like just like crushed it because this API was amazing. And like, you know, similar things are happening here. Okay. And sort of, you know, looking at the vibrance of the open source community for LLMs, you know, I think there is kind of a lot to learn. RWKV kind of stands out in sort of, you know, the crazy ideas that it's trying, but also, you know, there's a lot of efforts that are like kind of hybrid academic open source that are like trying new things like preference data or RLHF methods. And I think that's like really exciting. There's a lot of energy and trial and error there that doesn't really exist in academic research. And I think, you know, contributing to this, I think, is going to be really important to try to drive progress in our field. And so one of the reasons why I feel like this morning session has been great is because I think we've converged at very similar high-level philosophies of what's important. If we think about, you know, the energy that exists in the open source community and like how to like, I wouldn't say properly channel, that seems very top down, but like to try to shape it in a way that leads to like long-term, you know, innovation is to really think about like what produces innovation. So open source communities and also machine learning communities in general have really lived off of like contests. And contests have a very long history, and like the innovation mechanism of it is, you know, pretty well understood, right? You know, going back to like 1418, like the big dome on the Duomo, or like the Longitude Prize, or the invention of food canning, all of these things, right? Like by putting together like clear, you know, conditions of winning a contest and sort of setting the goals correctly, you can get a ton of people to come up with very good innovative ideas and to put that all together into some sort of very, you know, focused force. And so to do this, what's really important, are we good? Okay, sorry. You know, what's important is to measure progress, right? Like if we give people the wrong thing to hill climb on, then we're going to produce a lot of innovation for the very wrong goal. And so, you know, we have, you know, OpenLM leaderboard for base models, and like that seems okay for the most part. We got Chatbot Arena for like the real ground truth evaluation. And I guess my corner of this that, you know, I feel a little responsible for is like the automated evaluation aspect of all of this, which is, you know, the Alpaca eval thing that I mentioned before. So, you know, that's basically alongside MP-Bench, which is another really nice like multi-turn version of an evaluation mechanism. It's an automated evaluation scheme for chatbot-like systems. The way it just kind of works is, you know, you have an instruction, you have a baseline model that returns a response, and you have your model return a response, and then, you know, GPT-4 is used to judge which one is better with some, you know, crafted prompt. And, you know, there's a live leaderboard, and the reason why we originally released this was because we had some sort of evaluation data to be able to sort of like engineer and validate this thing. We had a bunch of usage data from the Alpaca demo. You know, we didn't release this for privacy reasons, so we basically have a bunch of usage data that we were able to use to see if sort of the instruction distribution was properly crafted. And then, you know, we can use this to, you know, rank RLHF models, and we knew that the pairwise evaluators were reasonably accurate from Alpaca Farm. I'll skip this a little bit. Oh, actually, no, I need the right side. So one of the things that we did check in the Alpaca Farm paper was sort of spurious correlates. So we kind of know that people like longer stuff. We also know that language models will give higher ratings to longer outputs. And so that's a little bit concerning because maybe language models prefer them longer outputs more than humans. So we had done some pretty basic checks So like preferences for lists, human is the blue square over here. Our best LLM, I think, is which square? The orange circle over here. This is length preference. Roughly human and model is pretty similar. But really, I think, looking back at it about 6 months later, I should have been a little even more skeptical, because actually Essen, who was my postdoc a while ago, and I had written a paper about how reference-free evaluations like Alpaca eval can have a lot of spurious correlations. And we've seen this really crop up in the last couple of months, I think, as like some of the startups and other people have like aggressively started to optimize against Alpaca eval. So one thing that you could do, which illustrates this problem, is you can just take a model and then you can prompt it to be more verbose. And that really just like boosts the Alpaca eval scores by like a bunch of %. And that seems a little concerning. Or if you make it less verbose, that'll like drop the score by a bunch, which is also concerning. And you've got all these open models doing really well with really long outputs. And the thing I love about Twitter people is they don't mince words. They're like, are you just measuring length, right? And that's a real concern. And so recently, one of the things that we've kind of learned from the open source ecosystem is like, these artifacts aren't static objects. We can actually improve them. And so we've been coming up with some like debiasing methods to try to control for length of outputs. The other thing that we now have is a big ecosystem of models. So we can use Chatbot Arena as a way to like sanity check the validity of our automatic evaluators. And then actually there's a bunch of people that have suggested to us different ways to try to correct for length. So that actually serves as a natural set of sort of baselines and ideas to try going forward. I don't want to get into too much detail, but one basic thing that works that's simple and also fun is to basically just fit a regression. So what we can do is we can try to predict, if you have a model M and a baseline model B, you can try to say like, can we predict which of the two models will win based on the identity of the model, the length difference of the models, and sort of the instruction difference, sorry, the difficulty of the instruction. Turns out that works pretty well. It's very simple 3-parameter or so regression. And it'll get you like 0.98 spearman correlation against Chatbot Arena. Of course, aggregate correlations are always not about robustness, but if we look at sort of the same attempts to gain the metric, it's much more robust to sort of say, doing things like be more verbose or less. And if we look at the ranking changes, it also makes sense. It takes all the open source models and pushes them down a little bit. And it takes, some of these sort of proprietary models, which I don't think are optimizing as Alpaca eval, and they get better rankings. Okay, so I'll wrap up here. I think doing the Alpaca project has been a really interesting experience, and sort of thinking about sort of the relationship between open source community and artifact releases in academia. One of the things I think is a high level question is like, how do we navigate this tension between LLMs as like research artifacts and sort of chatbots as user facing objects? How can we better work with and like harness the energy and like power of the open source ecosystem? And it would be nice if we could learn from and build upon a lot of what the open source folks are doing. I think there's a lot of interesting things there, even if it's not quite like the careful, rigorous stuff that academics traditionally like. Thanks.